Good morning, everyone. My name is Steve Lieberman, National Product Manager at Graybar, and I'd like to welcome you to Graybar's G2 Talk presentation this morning on migration to next generation applications. This talk is part of a webinar series we offer each month for our data communication customers. We have a great discussion lined up for you today, but before we get started, I'd like to cover a few housekeeping items. First of all, if you're one of the first 50 people who join in on this presentation, you'll receive a coupon for a free cup of coffee courtesy of Graybar as a thank you for your time. Also, at the bottom of your screen, you'll see a box for Q&A. Feel free to submit questions throughout the presentation. We'll address as many of those questions as time permits at the end of the presentation. In addition, this presentation today is worth 1 Bixby CEC credit. So if you stay on for the entire presentation, you can download your Bixby certificate right from this platform. Just click on the ribbon icon shown here, and you'll be able to download the certificate. Lastly, our G2 Talks are also archived on graybar.com website, so you'll be able to view this presentation again or recommend it to others. We're happy to team up today with CommScope, a global leader in infrastructure solutions for communications networks. As a data communications distributor, Graybar works alongside CommScope to ensure you have the technology you need to meet rising data center capacity needs. You can visit graybar.com to learn more about our solutions. At this time, I'm happy to introduce today's speaker, Steve Schmerber. Steve is a technical director at CommScope, responsible for field application engineers. Before beginning his career there in 1994, he worked for Avaya and Lucent Technologies. Steve has been a Bixby certified RCDD since 1986, NTS since 2009, and a DC-DC since 2014. He also welcomes visitors to the Claremont factory with technical updates and migration strategy discussions. Steve graduated from Texas A&M University in 1985 with a BS in Engineering Technology. So without further delay, I'd like to turn over the presentation today to Steve. Take it away, Steve.
Thanks, Steve, and thank you everyone for joining us on the call today. As introduced, I'm Steve Schmerber with CommScope. I'm one of 3 regional directors responsible for supporting you with Tier 2 and higher technical support. My job has been cable related from the very beginning of my work history when I started my career with AT&T, which spun off to Lucent, then Avaya, and subsequently purchased by CommScope. I've reached 30 years in the industry and am more excited today with technology challenges and opportunities than ever before. On the call today, I'm going to discuss options for migration to next generation applications. Many of you may remember late-night talk show great Johnny Carson. He was the king of late-night comedy, and I was a big fan of his. One of his regular bits was playing Karnak the Magnificent, where he would divine the contents of a hermetically sealed envelope presented to him by a sidekick, Ed McMahon. Karnak would somehow always know the answer to the question in that envelope, and most of the time we were laughing out loud in awe of his response. Inspired by him, I'm going to try to answer that age-old question, that age-old pain point, that technology demand that many of us are faced with as we update or upgrade our network infrastructure. What will my network look like in 20 years? Or maybe 10 years? Or maybe even 5 years? I often ask my business partners how they would answer that question, when and if they are presented with it. Most will launch into current product availability and future-proof with current availability, but is that necessarily answering the question? By the way, I'm not a big fan of product-focused conversations to begin with, as many of my sales team can attest to. Others will focus on current platform of products and maintain investing in the higher dollar next generation offers would result in wasteful spending. I think there is merit to both of these lines of thinking, but we'll offer an alternative answer to both. I've consulted Karnak the Magnificent, and the following presentation represents some of his divinations. To appreciate the complexity of where we'll be 20 years from now, or 10 years, or even 5 years from now, I'd like to first explore network trends we're facing today. What are some current trends impacting today's network demands? Let's focus on the following trends: bandwidth explosion, generation mobile, and the Internet of Things. Generation mobile. What does this mean to you? When I first heard this term, I immediately thought of my kids and the way they face business challenges and social opportunities versus the way I did earlier in my career. Many of those on this call, probably all of you on the call who actually heard of Carnac the Magnificent, grew up with personal offices equipped with telephones coiled to the wall and personal computers that took a long time to fire up. We conducted much of our business tethered to this office, and life was good. When we left the office, we made sales calls, or we actually really left the office. Today's workplace is a bit different, and for many of the millennials on this call, you probably couldn't survive being confined to an office for very long to conduct your business. The mobile workforce and telecommuting blossomed between 2005 and 2012, seeing 80% growth in telecommuters reaching 3.6 million workers. We realized the newfound mobility that gave us the opportunity to work socially using our smartphones and untethered laptops. Employees can now work out of homes, and office spaces are being reconfigured to accommodate these virtual office employees. Millennials, as well as many of us baby boomers, are working and playing socially. Does this make a difference in how we design our network infrastructure? Where has our network infrastructure demand shifted because of this newfound freedom? CommScope recently completed a survey focused on how we're serving millennials. Documentation that showed some curious differences between the millennial generation and many of us baby boomers. I'd like to read the following from that report. By 2025, millennials will comprise 75% of the global workforce and more than $8 trillion in disposable income. Millennials, those born between 1981 and 2000, are quickly becoming a financial juggernaut. In stark counterpart to the aging baby boomer generation, they have firmly asserted their influence as the emerging and soon dominant demographic for consumer spending in every major industry. Technologically fearless, cost-conscious, internet-empowered, strongly opinionated, and hungry for transparent communication, theirs is a truly mobile lifestyle. Based on these trends, I think we'll see a much different design in how networks are built out in the future. The demand is real, not just for the millennials generation, but for all of us who work and play online. I like this slide. How much of this applies to you in your internet minute? Although I can't really relate to the Tinder, Vine, or even the Facebook swipes and logins, I can take credit for some of those 150 emails sent every minute, those 2.4 million Google searches, and some of those 2.78 million YouTube downloads every minute. Who would have believed any of this was possible years ago? Like I mentioned earlier, I remember the days when I would turn on my computer, then I would go get some coffee, catch up on the previous day's phone messages, generate the day's to-do list, and then finally see my computer actually turn on. For real. So we use all these apps and pretty much expect immediate results. To accomplish this, the applications need to reside closer to the users. One mega data center cannot suffice, as many users will suffer delays to process transactions or to retrieve data. Traditional enterprise brick-and-mortar data centers are being shifted to the cloud, the multi-tenant data centers, or edge data centers. Edge compute platforms are being built out versus traditional core compute platforms to move that content closer to consumers, decreasing speed required to get access to that information. Let's now take a look at the Internet of Things. If you had to explain, oops, sorry. Sorry, I seem to have lost a slide. If you had to explain what the Internet of Things was, how would you? When I ask others to define what the Internet of Things means to them, I often get the response that it's the ability to see things through the Internet. I can see endpoints like video cameras and the video feed it produces via the Internet. Close, but let's explore this concept a little bit more. I like this quote from John Battelle. We mostly focus on the things and take the Internet for granted. But it is worth remembering that objects only become magical when connected in some way and data flows to and from them meaningfully. Everyone is talking about the Internet of Things, but it is only when these things connect that the magic really happens. CommScope is in the business of connecting things. We make the magic happen. We are foundational. I did some searching on the Internet to find out how big this could be and found the following data points about connected devices from different sources. This Salesforce slide said they are expecting 75 billion connected devices by 2020. And looking at some of the pictures connected, it's going to continue to get interesting. I can guess the umbrella is representative of weather forecast and events, and the game controller being representative of online gaming. All of this is available today and will continue to grow, but some of the other symbols has me a little stumped. That goldfish bowl in the bottom left. What are we connecting there? That key in the bottom right may be representative of IP locks. I often challenge my STEM students to visit our factory to start thinking of applications that they will develop when they are in the workforce. I'm looking for some cool apps when I'm long retired and my expectations are high. Other guesstimates included Gartner estimating 26 billion connected devices by 2020, Cisco and GE estimating 50 billion. IDC, Intel, and UN expect 200 billion connected devices. Estimates from a low of 26 billion to a high of 200 billion by 2020. Whether it's 26 billion or 200 billion, this represents considerable growth from where we are today. So where are we today? Look at the connectivity in the following industries. I believe everyone in this call can identify with connected devices in building automation, lighting controls, access control, or with energy meters, and may consider the percentage a little low in some cases. I'd like to see these numbers go up as access to these devices from afar can serve useful. If you had to guess what percentage this represents for all things globally, what would you guess? 25%? 10%? The percentage of connected global devices is approximately 1%. Plenty of room to grow here also. We need a lot more connectivity before we realize the true value of the Internet of Things, and CommScope will be a leader in developing and deploying that infrastructure. Having seen mobility trends and the move to connect and, more importantly, communicate with more devices globally, we now move to bandwidth explosion trends. Look at some of the trends represented on this graphic with mobile data, IP video, cloud data, internet traffic, and broadband traffic. What this is telling me is the network is going to have to step up again. annual global IP traffic will surpass the zettabyte threshold in 2016. 2 zettabytes in 2019. Global IP traffic has increased more than 5-fold in the past 5 years and will increase nearly 3-fold over the next 5 years. Overall, IP traffic will grow at a compound annual growth rate of 23% from 2014 to 2019. Over half of all IP traffic will originate with non-PC devices by 2019. I'm guessing most of these non-PC devices are for our smartphones, and many of those are probably now focused on Pokemon Go, right? Traffic from wireless and mobile devices will exceed traffic from wired devices by 2019. Global internet traffic will reach 18 gigabytes per capita. The number of devices connected to IP networks will be 3 times as high as the global population in 2019. Technology has enabled more and more applications, which can consume more and more storage. Cisco forecasts that by 2020, the average person will maintain 130 terabytes of data. Similarly, IDC forecasts a 44% CAGR in stored data through 2015, with over 7.5 zettabytes stored. This is heavily impacting our data centers, as they must accommodate this increase in data. Having looked at the generation mobile trends, the Internet of Things, and bandwidth explosion trends, let's now shift to standards and design. Looking at market trends is one way to predict and develop a plan for our future network demands and needs. Another way to predict our future network view is to consult the standards. The Ethernet Alliance developed this slide that demonstrates the need for speed because of the bandwidth explosion we just discussed. One of the things I first noticed about this slide was the starting speed at 40 gigabits per second, which was ratified in 2010. How many of you are running 40 gigabytes per second in your network? Many of you could say you've deployed a leaf-spine architecture utilizing QSFP transceivers in your data centers, but probably the majority of you are focused on enterprise applications requiring significantly less. 1 gig and 10 gig are popular Ethernet speeds, but due to 802.11ac needs, we're looking at 2.5 and 5 gig options also. How many of you remember Moore's Law? Do you remember what it foreshadowed? Gordon Moore in 1965 observed that the number of transistors per square inch on integrated circuits had doubled every year since the integrated circuit was invented, and would continue to do so in the foreseeable future. We translated that to network speeds, and we're instructing our customers to add a 0 to their network speeds every 7 to 10 years. 40 plus years later, we're still trending with Moore's Law. This is one of my favorite slides that demonstrates standards applications versus distance support. We've represented 10 gigabit Ethernet on the bottom portion of the slide, which highlights applications being utilized in campus and data center applications. And we've represented 40 and 100 gigabits Ethernet on the top half of the slide, which is being utilized in many of our enterprise and service provider customer data centers. For shorter top-of-rack needs, you see the twin-X cabling represented on the left of the slide, and notice its limited distance support of 7 meters or 15 meters. We see 10 gig base T, which is 10 gig over twisted pair that is limited to a familiar 100 meters. As we migrate into multi-mode options, we can see the distance limitations of OM1 and OM2 fibers for 10 gig applications. giving way to OM3 and OM4 for longer lengths per applications. For the 40 and 100 gigabit Ethernet applications, there is no support for OM1 or OM2 cables. OM3 and OM4 is shown at 100 and 150 meters. The single mode infrastructure gives the longest distance support for all three options of 10 gig, 40 gig, and 100 gig. This slide looks at building regulations and standards. To do a deep dive into all the regulations and standards that facilities, IT, data center managers face within their spaces would be cumbersome and time-consuming. There are IEEE standards focused on physical layer, automated infrastructure management, power, wired, and wireless. Adhering to these will give you a great foundation for your future intelligent building and/or data center. There are a few standards, specific standards I'd like to highlight that may help you. We'll first focus on applications and design considerations affecting your copper cable decision. Let's look at some other specific standards that may help you choose Category 6A as the ideal infrastructure. In the Standard for Educational Facilities, ANSI TIA 4966 calls out Category 6A as the copper cable of choice. Likewise, for healthcare facilities, TIA 1179 recommends that cabling infrastructures be designed with Category 6A cable. Many large file applications, for instance, CT, MRI, PET scans, are often very large files. A 10 gigabits per second infrastructure will help you transfer many of those in a timely manner with fewer disruptions. For intelligent buildings, there are a number of current and future applications that will also strain your existing cabling infrastructures. Probably the most significant application approved in January 2014 was IEEE 802.11ac. IEEE 802.11ac supports increased performance and capacity with peak data rates up to 6.9 gigabits per second, more than 10 times the top speed of IEEE 802.11n. Our recommendation for this Wi-Fi application is to plan for 2 Category 6A cables to each access point, preferably using a zone architecture. There has also been a lot of press about the future of PoE as we add more and more connected devices to our cabling infrastructure, preferably without having to work with local power. 2003 standard of 15.4 watts for PoE applications was upgraded to 30 watts in 2009. Device and power management manufacturers have been well ahead of the curve, offering devices that are beyond current standard support. The new standard, IEEE 802.3bt, is intended to deliver up to 90 watts of power to PoE-enabled devices, assuming a 100-meter channel. The latest data center standard, TIA 942, also recommends Category 6A for copper cable considerations. There are obviously a number of other applications and standards that are either written or are being drafted to reflect Category 6A recommendations. CommScope's latest DAS, or in-building wireless solution, requires Category 6A cable to support its distributed antennas. We've looked at trends or market drivers. We've looked at standards. Now let's look at our personal history with structured cabling, where we've been and where we're heading. How has our business grown throughout the years, and how has our bandwidth growth affected the wired network speed over time? For the most part, the speed of the network connections to the end devices has increased by a factor of 10 over a 7 to 10 year period, mirroring Moore's law. If you were supporting 100 base T applications in 2000, Due to the new devices, demands you evolved to Gigabit Ethernet prior to 2008. We just discussed a number of new applications where Category 6A would be required to support those devices. Let's move the discussion to the aggregated backbone trunks. You can see OM1 or OM2 or 62.5 micron fiber was sufficient to support backbone traffic in the past. And most of us have seen that 62.5 micron fiber is not adequate to support us for our current needs. We've seen an upgrade to OM3 or OM4 fibers for that backbone traffic. Those of you who are in data centers, you have seen or are facing the next generation demands of parallel optics to support 40 gig or 100 gig backbones. We've seen our fiber connectors also move from ST to SC to LCs in all of our 10 gig electronics. As our customers migrate to 40 gig speeds and beyond, we're seeing MPO connectivity, parallel optics, and pre-terminated solutions. The QSFP pluggable connector shown in the middle of this slide utilizes 4 transmit strands and 4 receive strands out of the 12-strand lanes. Ports offer the possibility of a 40 gig channel or 4 by 10 gig channels. For MXP or CXP transceivers, a 24 fiber MPO can be similarly broken out to 1 by 120 gig lane, 3 by 40 gig ports, or 12 by 10 gig ports. There are a number of switch manufacturers, including Cisco, Arista, and Juniper, to name a few, that are manufacturing and selling these type switches. For legacy installations, we are also seeing BiDi or bidirectional transceiver offers that take existing duplex fiber links and offers 40 gig transmission utilizing wave division multiplexing technology, 2 by 20 gig lanes for transmit and receive. This is great for those customers who want a quick fix utilizing their current infrastructure, but may not necessarily be the right choice for new facilities. Earlier, I spoke of some of the trends within the data center space. Another trend taking place in the data center space is the migration from a traditional 3-tier architecture to some sort of leaf spine architecture. This slide shows what we mean by a traditional 3-tier architecture. You can see represented in the 3 layers are the access layer, aggregation layer, and the core. Much of the traffic in this architecture has to travel from device to access, to aggregation, to core, back down to aggregation, back to access, to get to the other end device. This is also referred to as north-south traffic, and the multiple hops could result in high latency concerns. Data center designs and architectures have evolved to accommodate the growth of cloud-based storage and compute services. Traditional private enterprise data centers are adapting their current architectures to prepare for new, agile, cloud-based designs. These new enterprise architectures resemble warehouse-scale facilities, but are designed to support many varied enterprise applications. To prepare for cloud architectures, an optimized direct path for server-to-server communication is achieved with leaf-spine architecture as represented on this slide. This design allows applications on any compute and storage device to work together in a predictable, scalable way regardless of their physical location within the data center. Cloud networks are based on an architecture consisting of meshed connections between leaf and spine switches. The mesh of the network links is often referred to as a network fabric. The performance of the fabric is well suited to establishing universal cloud services, enabling any-to-any connection with predictable capacity and lower latency. The fabric has inherent redundancy, as multiple switching resources are spread across the data center, thus helping assure better application availability. These distributed network designs can be much more cost-effective to deploy and scale when compared to the very large traditional centralized switching platforms. Network fabric design could get complicated if chassis-based switches and zone cabling architectures aren't utilized. Similarly, certain polarity methods may also complicate migration strategies. I would be remiss if I didn't talk about disruptive technologies that could impact our future data center design, as this space will be the most likely to experience major technology shifts to the growth and spend. CommScope has invested a significant amount in R&D to address the transformational needs in this space. Strong players like Cisco, Dell, and HP are being disrupted by dumb switches and smart software. For instance, SDN, or software-defined network, is an example of smart software. The new architectures are looking at different cabling strategies, and our traditional parallel multi-mode VCSEL technologies may see pressure from a serial single-mode silicon photonic transceiver. Can you imagine how much of an impact this would have in our industry? Single mode being more cost-effective to deploy than multi-mode. This slide is similar to the earlier slide that showed application support versus distance limitations. Specifically, it takes a closer look at distances supported based on fiber type and application. The left column, top to bottom, shows different fiber types, starting with legacy 62.5 micron fiber, then 50 micron optical multimode, laser optimized multimode fiber, and includes single mode OS2 fiber. We can now look at distance capability for gig Ethernet, 10 gig, 40 gig, and 100 gig Ethernet. Note the distance support for 40 gig and 100 gig doesn't allow 62.5 OM1, OM2, or OM2 plus cable. OM3 offers 40 gig and 100 gig support to 100 meters, whereas OM4 laser optimized multimode fiber is specified to support in excess of 150 meters. OS2 single mode offers maximum support for data centers applications, but is costly for shorter distance support. Looking ahead, there are a number of choices for higher speed links. Some vendors advocate single mode optic solutions. Others advocate multi-mode optics. For each of these media choices, there are potential duplex and parallel channel options. The relative cost of those options continues to evolve rapidly. Some basic relationships still hold. Multi-mode optic systems continue to be lower in capital cost and are perhaps easier to maintain and operate compared to single-mode optic systems. So where do you and I go from here? That earlier Ethernet Alliance slide showed speeds of 400 gig and beyond. Are we locked into single mode for those next generation applications? And oh, by the way, what is that wideband multimode fiber all about? Looking ahead to 100 gig and beyond, one of the more promising methods of increasing network capacity involves adding more communication channels to each duplex pair of multimode fibers. While wavelength division multiplexing technology has been available for single-mode optics at a high cost, new shortwave division, new shortwave division multiplexing transceivers will combine 4 channels on a fiber pair, gaining 4 times the capacity on multimode fiber. This lower cost alternative combines the ease of installation and operations of multimode fiber with the bandwidth scaled up to support the growth fabric networks will require. In support of shortwave division multiplexing, CommScope, together with other members of the Shortwave Division Multiplexing Alliance, have developed the new wideband multimode fiber media, or WBMMF. This fiber is designed to expand the available capacity of multimode media, enabling more communication channels per fiber at a longer reach. Wideband multimode fiber will be used to deliver higher data rates of 100 gigabits per second and 400 gigabits per second, while reducing the number of fibers required to support these future high-capacity fabric networks. In April 2015, Finisar presented this technical demonstration. 100 gigabits Ethernet on a single pair of OM4 fibers, 225 meters on a wideband multimode fiber sample. The wideband multimode fiber standard developed has been carried out by a task group with joint oversight of TR 4211, which is the Optical System Subcommittee, and TR 4212, which is the Optical Fiber and Cable Subcommittee. The task group has approved TIA 492 AAAE wideband multimode fiber specification for publication. Another standard that has been discussed, defined, and published is ISO IEC 18598, Automated Infrastructure Management, or AIM for short. The purpose of an AIM solution is to provide end-to-end visibility of the physical layer. An AIM system provides the missing link between network or data center management tools and the physical infrastructure that connects network devices. In short, the AIM Intelligent Overlay knows exactly what is connected, how it is connected, and where it is located. How important will this be as we migrate to the next generation applications we've discussed throughout this presentation? Imagine having the complexity of the leaf-spine architecture, utilizing a 120 gig switch port as 3 by 40 gig switch ports, each of which going to different parts of your data center. How will you map that on a spreadsheet? How will you know where those endpoints are within your data center without some sort of AIM tool? Current cable management techniques, including DSIM software, will not be able to support the one-to-many complexity. Ultra-high density solutions are also making tracking and tracing current connections in an equipment room or data center complicated. Labels are misread, they're lost, or they're just plain wrong, resulting in extra time to resolve errors in network outage. We're also scaling often beyond our confined space and need that real-time access to cable records and connected devices. AIM solutions have been available for a number of years, and similar to Category 6A, the true value really hasn't been realized until just recently. It's time to take a fresh look at Intelligent Overlay and what efficiencies it can afford you. With my final comments aiding you in your migration and next generation applications, I want to highlight some recommended tools that will also help in your design efforts. The higher speed applications come with lower loss budgets, right? But often also may require more connections. It would be nice to have some tools to know if a specific cable type can support a specific distance with a specific number of connections with a specific connector type for a specific application. Did you hear how many variables there were in that statement? This has been a challenge since day one, and we've published application guides and performance specifications that can help you here. We've also got some great online tools that does just that. This performance specification represents fiber channel apps from 1 to 16 gig and Ethernet apps from 100 megabits per second to 100 gigabits per second. A deeper dive into any of these applications shows different fiber types and supported distances for different number of connections. Some of the other tools will help you look at expected link loss for any given channel based on fiber type, connector types, and number of connections or splices. There are other configurators and tools that will help you determine best practices for building out your building or data center. And we have a number of sales and technical resources that can also help. Having said that, I want to encourage you to get with your local CommScope or Graybar account manager or any of CommScope's field application engineers to further discuss anything mentioned during this presentation. It's been my pleasure to discuss migration to next generation applications. On behalf of CommScope and Graybar, thanks for your time today.
Thank you, Steve. That was an excellent presentation. At this time, we'd like to address some of the questions that have been submitted. As a reminder, you can submit a question using the Q&A box at the bottom of your screen. If we don't get to your question, a Graybar representative will follow up with you after the presentation. I want to make a few more comments here. If you'd like a copy of that Millennials report, please respond in the Q&A section and just put report. When we get that response that says report, we'll know to send you that link for that Millennials report. Also, if you'd like to have your local Graybar CommScope representative get in contact with you, put contact in the Q&A section. So if you put contact in there, we'll have someone contact you in your local market. If you put report in there, then we will make sure you get a link to that Millennials report. So Steve, at this time, we've got a few questions we'd like you to address. First one is, again, well, how can you get a copy of the Millennials report? We just answered that one. That will be on the CommScope's website, but yep.
Let me comment on that. It is on our on the CommScope website too, or at least a link to get it is on there. And if you go into www.commscope.com, there's a search field on the top, and you can search for Millennials, and there's quite a bit of documentation there and access to get that report. There's also white papers and application guidelines and all the tools that I just mentioned a minute ago, calculators, labeling templates, stencils. There's a wealth of resources located online, and actually by hitting the resources tab, you can download quite a bit of resources that can help do a lot of what I talked about during the presentation.
Okay, thanks, Steve. The second question, which AIM platform will CommScope be moving forward with?
So that's a smart question. Somebody knows that with the recent acquisition of TE BNS, we kind of inherited two platforms. We've got the Envision, which was traditional SystemX, the CommScope SystemX AIM system, and we also have Quorio, which was part of the legacy BNS AIM system. And what we're doing is we're going to continue to support both AIM products because both of them have some great features. Both solutions will continue to be available to the market while we develop the roadmap for a single combined AIM solution that leverages it'll actually leverage the strength of and the advantages of both the Envision and the Quorio systems. So stay tuned for that. There's some great features in both systems that we're going to kind of merge into one. Okay, good. We have another question here. Is wideband multimode fiber available today? Yeah. So we do have products available today. We've got a complete channel solution, actually. LC MPO modules, the trunks, the 12 to 144 strand low-loss trunks. We've got fan-outs, MPO array fan-outs. We've got patch cords. And by the way, you'll recognize all these products by the lime green color associated with them. It's it's a step above OM4, so we're taking a step away from the aqua, and you'll recognize these in the lime green kind of jacketing color. All of them are at Graybar. You can purchase them all today from Graybar. Thanks, Steve. We have another question here about the same topic. Is wideband multimode fiber backwards compatible with existing fiber optic cable? Yeah, so it's similar to OM3 and OM4. We can work previous generation applications, so gig, 10 gig, 40 gig, 100 gig, and beyond we can do with the wideband multimode fiber. And matter of fact, we're kind of recommending it. We're installing an infrastructure that can support current applications and next generation applications, and that's one of the reasons why we're rolling it out to when we have. Similar to Cat 6a, I would guess that most of the folks on this call wouldn't remember that we actually rolled that product out in 2004. So it's been out for 12 years, and we're finally seeing applications that we can really, demand the need for Category 6a. We're kind of ahead of the curve with the wideband multimode, and we'll see these applications come out, and we want to encourage our customers to consider that, to deploy that product now to support current applications and that next generation demand.
Okay, good. Thank you. Another question here about that topic. Is there specialized testing for wideband multimode fiber?
So I'm going to say yes and no to that. Yes, in regards that for OM4 fiber, OM3, latest current generation testing, we encourage the latest generation testing devices. Those that support encircled flux and look for encircled flux measurements. Basically, the latest generation testers are able to wipe out some of the uncertainty in testing our fiber, and we can get that fiber better qualified with these next generation test sets. Current test sets will work for wideband multimode fiber. We do not need the fact that we're testing 850 nanometers and 1300 nanometers. These wavelengths are in between, and so the physics of class is that we will not need another test set to look at these additional bandwidths.
Okay, Steve, it looks like we have a couple more questions on that topic. It's a popular topic. Has the industry blessed lime green as the color? I know you mentioned lime green. Do you know what that current, is that official lime green?
I don't know that for sure. That's the stump the chump question right there.
Okay.
I don't know that for sure.
Okay. Well, we'll get that answer to the person that submitted that question. Another one. Again, since you talked about topic, maybe you can answer this one. Can 50 micron OM4 fiber be used for wideband multimode fiber?
And 50 micron, I don't understand that one. It is. I'm not real sure what they're asking on that one. Wideband multimode fiber is a similar to an OM4 fiber. It is a 50 micron fiber. It's just now it's got the bandwidth support of the additional bandwidth. So I'm not sure what they're looking at there in that question. Sorry.
Okay. It's all right. We'll try and get another answer for them. We've got a couple more there, Steve. You can look at the Q&A. We still got a few in the queue there that we're going to try and get to. We've got a few more minutes before we can download that Bixby certificate that we want everybody to be able to access. So can you expand a little bit on, again, this may be a quick answer or we may get it from the copper division, but which is faster, Category 6A or 6E?
So I don't know. When I hear about 6E, it's not standards based. Category 6A is the 10 gig copper cable. Category 8 is the 40 gig that we focus on. 6E is, I think, different manufacturers represent it differently. So I would focus on Category 6A as the 10 gig compliant copper cable.
Okay, and one here, we'll see if, again, this might be your speculation, but you think the wideband multimode fiber would be called OM5?
Yeah, there's good indication that it will be considered an OM5 fiber.
Okay, good. Steve, you can take a look at those last couple questions. If we don't get to those, we'll make sure we get those answers to the participants that submitted those. I want to remind everyone that you can download your BIXI certificate by clicking on the ribbon on your screen, and then you'll be able to download that and submit that for your BIXI credits towards renewing your RCDD or whatever certification you need to earn those credits for. So, Steve, do you have any other final comments there before I do the wrap-up?
Nope. I appreciate Graybar's offering this opportunity to me and CommScope, and thank you very much.
Okay. So again, if anyone has any more questions, you can submit those online, and we'll get you the answers. Put contact, and you'll have a Graybar or CommScope rep contact you. If you put report in there, then we'll send you the link to that Millennials report. So we're about out of time at this point. Again, don't forget to download your certificate. If we didn't get to your question, we'll follow up with you after the presentation. As a reminder that this presentation will be archived on graybar.com website. Thank you for your time today. We hope you'll join us again next month for Graybar's G2 Talk seminar. Thank you.